Okay, so we're going to continue now with examples 3 and 4 with solving quadratic equations. And these are going to be slightly different than the first two. You'll see why in just a few moments. All right, so number 3, we're going to start it the same way. Nothing's going to change from what we've been doing to what we're doing right now. With that in mind, we need to get it set equal to 0. So I'm going to subtract 168 from both sides. So we have 2x squared plus 12x minus 150 equals 0. Okie dokie. Now, step 2, factor out a greatest common factor if possible. So in this case, the term here has a factor of 2, which 12 is also divisible by 2. Negative 150 is divisible by 2, so 2 is our GCF. Let's factor that out. Dividing each term by 2 along the way. Now, step 3, divide both sides by the GCF if possible. So I'm going to divide this side by 2, which is going to cancel it out, and divide by 2 on the right side as well, which leaves me with x squared plus 6x minus 75 equals 0. Now, what that does, by factoring that 2 out, it has made our solution a little simpler in the sense that we don't have as big a numbers to worry about now. Compared to the 150 and the 12, we now have a 75 and a 6. So let's think for a minute. What are the factors of 75? We've got a 1 and a 75. It's not divisible by 2. It's divisible by 3 25 times. Not divisible by 4. Divisible by 5 15 times. Not divisible by 6 or 7 or 8 or 9 or 10 or 11 or 12 or 13 or 14. Now I'm back to 15. So these are the only possible factors that would give us a product of 75. Now, we need a pair that have a difference of 6. In this case, none of them have a difference of 6, which tells me this one is not going to factor into two binomials. When that happens, you need to use what's called the quadratic formula. The quadratic formula, I'm going to write this up here at the end of my little set of notes so that you have it if you should need it. For the quadratic, so the quadratic formula, x equals, and x is your solution, like here we have x equals, the opposite of b. So if b is a positive number, it'll be a negative b. If b here is a negative number, then the opposite of it would be a positive. But the opposite of b plus or minus the square root of, and all of this is going to go in the square root, b squared minus 4 times a times c. And remember, a and c are these two numbers here in our quadratic up at the top, all divided by 2a. All right, so in this case, in our solution down here in number 3, we're going to use that quadratic to solve it. So x equals, let's deal with the numerator first, the opposite of b, so the opposite of 6 is negative 6, plus or minus the square root of b squared, so b squared is 36, minus 4 times a, which is 1, times c, which is negative 75. So 4 times 1 times negative 75 gives us a value of negative 300. Now 36 minus negative 300 is going to make that plus. All over 2 times a, and a is 1, so it's just going to be 2. All right, now we need to simplify what we can in the square root. So 36 plus 300 is the square root of 336. This is an instance where simplifying the square root is an absolute necessity. So let's see, 336 is divisible by, is it divisible by 16? I'm looking for a perfect square that it's divisible by. It is. So the square root of 36 splits apart into the square root of 16 times the square root of 21. We know the square root of 16 is 4, and the square root of 21 doesn't simplify. So I'm going to replace this square root of 36 with 4 square root 21. Now, why is that useful? Because now I have two whole numbers, the negative 6 and the 4, that are both divisible by 2. So I'm going to divide the 2 into this negative 6 and into that 4, which produces negative 6 divided by 2 is negative 3, plus or minus 4 divided by 2 is 2. And remember, this square root is unaffected by the action taking place with these integers. And those become our two solutions for x. Here again, you can check it and make sure they work. I would advise you to do that on all problems. This one does work, as I've checked it before. All right, so at this point, I would say pause the video and try number 4, and then come back to it. All right, let's look at number 4 then. Same general process. I want to start by getting it set equal to 0 and in descending order. So we're going to subtract 11 from both sides, which is going to produce 6x squared plus 9x minus 6 equals 0. Step 2, look for a common factor. So what are 6, 9, and negative 6 all divisible by? They're all divisible by 3. So let's factor out a 3. 2x squared plus 3x minus 2 equals 0. Okay, I want to divide both sides by 3. When I divide by 3 on the left, I'm going to end up with, keep wanting to write that parenthesis, 2x squared plus 3x minus 2. Dividing by 3 got rid of that factor out at the front. When I divide on the right side by 3, 0 divided by 3 is 0. Okay, so now let's think about how we can factor this and if it will factor. A lot of times it's a matter of just trying it, and you may find it doesn't work, you may find it does. You could go straight to the quadratic formula every time if you wanted to. It always works. Factoring doesn't always work. Okay, so let's think. First terms have to multiply together to give me a 2x squared. The only way to get a 2 as a product is to multiply 2 times 1. And the x squared is x times x. So 2x times 1x. 2x times x. All right, on our last term, here again we've got a negative 2. Remember, if this were a positive, then I'd have to be cautious about what kind of terms I'm going to end up with. But we're going to find those in the check, if nothing else. So in order for this to be a negative, one of them has to be a positive, the other has to be a negative. The only way to get a value of 2 is for one of them to be 2 and the other to be 1. Now, let's see what happens. I need my middle term to be a 3. So what we've tried all along is to put this number, the bigger number with the plus, and the smaller number with the minus. But watch what happens when I check my outsides and insides. So first term is 2x times x, 2x squared. The last term, 2 times negative 1, does give me negative 2. But the outside and inside, 2x times negative 1 is negative 2x. The insides, I get a positive 2x. Problem that I have is those drop out, which means the way that I have them factored is altogether wrong. So let's try to factor it a different way. So scratch that, try again. Let's see, first term is 2x, last term is x. Let's see, I need a minus 2, so I'm going to put the plus here and the minus there, and I'm going to reverse my 2 and my 1. So let's try it with a 1 here and a 2 there. Let's see what happens. So outsides, 2x times negative 2 is negative 4x. Inside gives a positive 1x. So let's see, that's going to produce a negative 3x, which is close. When that happens, when I have the right digit but not the right sign, that means my signs, my plus and my minus, are backwards. Means I have the numbers in the correct position, just not the signs. So this one needs to be a plus, that one needs to be minus, like so. So that now if I were to check my outside and inside, see what happens. Outside 2x times 2 is 4x. Inside negative 1 times x is negative x. 4x minus x is 3x. So we've got it factored correctly now. Once we have it factored correctly, then it's time to separate it into two equations. So here 2x minus 1 equals 0, or x plus 2 equals 0. Add 1 to both sides, divide by 2, x equals a half. In this case, I'm going to subtract 2 on both sides, so x equals negative 2. And then we can check our work to see that those are going to work. For the sake of time, I'm going to tell you that they do.